Hi everyone, my name's Atos. I'm the product director at zkPass. So thank you for the invitation from Nibiru, and also a big thank you for you guys who took time to watch the stream. And zkPass is extremely proud to be one of the sponsors for Nibiru's Cataclysm Hackathon this year. So my name's Atos. I'm the product director at zkPass. zkPass is a browser-based protocol for verifying private data. So essentially what you guys can see us is a private data oracle. We bridge off-chain private data on-chain. So our tech stack stems from the state-of-the-art fields of cryptography, especially on zero-knowledge and multi-party computation. So just a little bit of background and overview of where we are right now. We're backed by Sequoia, OKX, Binance, and a bunch of other VCs. And we've just raised, we raised our 2.5 million seed round. And right now until then, we moved from our pre-alpha testnet to alpha and now to mainnet. So we've accumulated over 1 million zkSPTs across multiple networks to date. And as you can see, we worked with a bunch of chains and a bunch of different ecosystem partners. Currently, we have over 100 partners right now, announced partnership, and we have something that under the pipeline that we're collaborating with them. So yeah, so just a little bit of what zkPass is capable of doing. So you see here, there's my Binance account, there's this user ID, and wallet address. So when you think we're able to fetch that data over on chain in a zk like privacy preserving way, we're talking about like any data from any account from any website. So what we're able to do is we're able to first extract the private data from the website using a predefined schema, and then we're able to generate proof using the private data using zero-knowledge technologies, and finally submitting the proof on-chain as is SPT or verifiable credentials for example, some DID wallets. So we're able to, so we're not only able to verify Binance stuff, we can verify essentially any website. So if you can see, like, for example, Gitcoin Passport, they use the O authentication method. So what you're able to do is fetch over platforms, private data of platforms that utilizes the O authentication method. But what we can do is essentially bridge over any HTTPS based website that has a login and that uses TLS. And so that includes, for example, government issued documents, online credentials, real world assets, and we're also able to monitor metrics from enterprise systems that involves customer information without exposing any confidential data. So the capabilities of zkPass and our SPTs actually unlocks a vast amount of use cases and applications. And we're able to act as oracles for private data. As I said, we're bridging the gap between Web 2 and Web 3, and we're enabling the apps to use credentials and data coming from traditional Web 2 sources so that you guys can perhaps, leverage on the existing reputation or popularity of these Web 2 Web 2 social platforms or whatever other data source that you want. And, like hyperscale your startup. So as you can see, so the attestation usually it goes through a few steps before you actually use them, right? And this is essentially the basic life cycle of a attestation. So first of all, you generate, and then you compute, and then you store, and then you use. So with the generation part, previously with oracles, you usually bridge over public data with what, for example, what Chainlink did. You're able to like bridge some data from a public database that is collaborating with Chainlink. What we're able to do is we're able to bridge over any private data, and we can do this permissionlessly. And so basically, you would generate the private data from any website, and then you would start computing that data, right? And so to this part, we have multiple ways of actually computing the data, but still serving it in a privacy preserving way. So the way you would do this is, for example, you would use zkPass, or you could use some sort of zkVM, right? And so there are multiple ways, multiple projects that allows you to do this. And then after computing that data and turning it into valuable information, you would have to store it somewhere, right? Regarding to storage, there's two options. There's the on-chain options, which allows you to store it into any blockchain, in this case, the Nibiru blockchain. And with off-chain, you're able to store it in a Arweave server or Filecoin, or you can like even store it in a centralized database in a Web2 setting. So maybe Google Cloud or something. Like there's no limit to how you want to store the attestation. And for the usage, there's so much, as I said, like it unlocks a vast range of use cases, right? So I didn't have too much. I'm running out of spaces, but essentially this solution can be used with anything that is slightly related to reputation or slightly related to identities. We are able to use them, or even like we can, for example, we have a product called the AccuDrop, and that product essentially allows you to do targeted marketing on Web3. And previous, like target marketing is something in Web2 that is very, very common, but it has never been feasible in Web3. So what we're able to do is, for example, allows projects to incentivize their airdrops to the correct community or correct audience. And for example, if your project focuses more on like high value customers, you can first require the users to verify that their bank balance is over a certain amount, or they are perhaps a person that owns a lot of properties, or perhaps they are an experienced player in CS:GO for an FPS game on chain, right? So there's a lot of different use cases that attestations could be. So let's get right into how exactly where the protocols ran in the backend. So the protocol runs usually in three steps. So the first step is the prover and the verifier joins together to establish a secure TLS connection using MPC with the server. And then extracting a selective field from that data source using a predefined template. So going back to the Binance example, you're essentially extracting the Binance balance. And so, so in this case, you would extract the balance field from that data, the Binance data source using a predefined template. And the zkPass uses MPC to introduce a new entity within the connection, but the node is still oblivious to the contents that was transferred within the connection itself. So yeah, so this is the first step, establishing a secure connection. We sabotage the part of the MAC key to ensure that the connection is still the same connection that was established, and the client would have to incorporate the node with every communication in order to, even facilitate the communication. So that's the first step. And then the second step, after we've extracted that exact field from that from the data source, the prove and the verify would then compute the zk proof using a vol-based IZK. So what this means is, for vol-based is, for those of you that do not know what vol means, it's basically vector oblivious linear evaluation. So what it does essentially is it breaks the circuits into small instances that is vector linked. So you're able to break them into very, very small instances, but still be able to pass them into different nodes for verification. So that allows parallel computing of the circuit itself, and after all the computation is done, it's sent back to the prover, and then the prover can chain them all together. So yep. So this is what vol basically means. With our vol-based IZK, we're just like breaking them off and sending it over, and then them encrypting in them, and then passing it back to the client, and then this goes multiple times. So it's interacting between each other for more than once. So that's why it's interactive. So what it does is essentially it outputs a zk proof that proves that the field do in fact exist within the data source, and that the statement is valid. So yeah, so basically it's what it means, what the slide says. So the prover then sends the zk proof back to the blockchain as an SBT. So you're basically storing it in a blockchain. We're assuming that you want to store it on chain, together with all the necessary fields to construct the token. So within these three steps, each outputs different stuff. So the first one requires the user, the programmer for the project to construct a schema that is used to fetch the data when the user clicks verify. So there's a schema here, and so going back to the Binance example, you're essentially fetching the Binance balance. So basically, you're telling telling the extension to fetch over that exact go to the schema, refer to the schema ID, and then fetching that schema. Within that schema, it tells the extension to fetch that exact field right out of the data source. So yep, so that's basically how it works. And then it generates the zk proof after bouncing. The field is bounced off both the prover and the verifier, and then the field is the zk proof is generated, and then that zk proof is then submitted on chain. So this is a very, very you might be able to just pause and just look into this, but essentially what this does is it's basically going back to the Binance example, where we're constructing that schema, and then this is basically what it outputs. So there's the task ID, there's the public field, and then there's also the allocator and the validator, which is essentially the two nodes that is used to compute the proof. The allocator is allocating the task to the validator to compute the proof. So, but it's still within the same process. So we have a hash for both. So, yeah. So that's basically how it works. And then lastly, there is gonna be an output of that all the hashes, and then you would encode that hash and then submit that on chain, and that submission would be the input data for the SBT. So let's get right into the demo. So basically, here's the dev center, and we would want to first connect the wallet. So I'm going to my MetaMask here. And as you can see, there's an app ID, right? And that app ID is essentially an API key for you to, for the application to then refer back to the project that is used. So in this case, the domain name is also very important, because the dev center would then refer that back to your website. And now you're going to the schema. So the schema was basically what I've just inputted in the schema is the input that the schema input that I had on the slide. And after creating that schema, in this example, we're inputting it into a like a demo, just to show that just to show what is outputted right out of the minting process. So I'm gonna click run here, and now it goes to my Binance account, where I would then have to log in. Now I click start, and it goes to the Transgate. So this is essentially activating the schema, and it then goes to create that zk proof, and then that JSON file, the JSON output is then outputted in the demo as well. And what we've basically done is we've submitted that parts of that field on chain, and you would click confirm. Yep, and basically that's it.